Hello everyone, welcome to Zoom in Data. In this AI 900 learning series, we will learn the fundamental concepts of artificial intelligence and explore Microsoft Azure AI services. This series is designed to help you understand the key concepts required for the AI 900 certification. Image classification is a computer vision technique that assigns one or more categories or labels to an image based on its visual content. A machine learning model learns patterns from labeled training images and uses those patterns to classify new images. Classification focuses on identifying what type of content is present rather than determining the exact location of every object. It is widely used in areas such as product recognition, medical imaging, document processing, quality inspection, and content organization. The process begins with a collection of images that have known categories or labels representing the desired classes. During training, a machine learning model learns visual patterns such as shapes, textures, colors, and object characteristics associated with each class. After training, the model receives a new image and calculates which class or classes best match its learned patterns. The result can include predicted labels along with confidence scores that indicate how strongly the model supports each prediction. Image classification requires representative training images that cover the visual variations expected in real-world data. Each training image is associated with a label that identifies the category the model should learn to recognize. For example, a dataset could contain images labeled as cats, dogs, birds, or other animal categories. Accurate labels, sufficient image diversity, and balanced representation of classes can significantly influence model performance. Binary image classification predicts one of two possible categories for an image. For example, a quality inspection system can classify a product as defective or acceptable. A medical image model could be designed to classify images into two defined categories based on the specific task and labeled data. Binary classification is appropriate when the business or application problem has two meaningful outcomes. Multiclass image classification assigns an image to one category from three or more possible classes. For example, a manufacturing system could classify products as Type A, Type B, Type C, or another product category. The model learns visual differences between multiple classes using labeled training images. Multiclass classification is useful when an image belongs to one primary category selected from several possible options. Multilabel image classification allows an image to receive multiple labels when several categories can be true at the same time. For example, an image could contain labels such as car, road, tree, and building simultaneously. The model evaluates multiple possible labels instead of forcing the image into only one category. Multilabel classification is useful for image tagging, content management, search systems, and visual metadata generation. Image classification models are trained using labeled images and validated using separate images that were not used to fit the model. Training helps the model learn visual patterns while validation helps assess how well those patterns generalize to unseen images. Data augmentation techniques can create variations such as changes in rotation, cropping, brightness, or scale to improve robustness. A separate test dataset can be reserved for final evaluation after model development and tuning are complete. Image classification models can be evaluated using metrics such as accuracy, precision, recall, and F1 score depending on the task. Accuracy measures the proportion of predictions that are correct across the evaluated dataset. Precision measures how many images predicted as a particular positive class are actually positive, while recall measures how many actual positive examples are correctly identified. A confusion matrix can provide a detailed view of correct predictions and different types of classification errors. Image classification identifies the category or categories present in an image, while object detection identifies individual objects and their locations. Classification may answer what is in the image, while object detection can answer what objects are present and where they are located. For example, classification can identify an image as containing vehicles, while object detection can identify individual cars and their positions. Choosing between these techniques depends on whether the application needs image-level labels or object-level locations. Azure AI services provide computer vision capabilities that can support image analysis and visual understanding scenarios. Azure AI Vision can analyze images and return information about their visual content using pre-built capabilities. Custom vision scenarios can use labeled images to build models for specialized classification requirements where general-purpose models are not sufficient. For AI 900, it is important to understand image classification as a computer vision workload and recognize the appropriate Azure services for visual analysis. Image classification uses computer vision and machine learning to assign categories or labels to images based on their visual content. Binary, multiclass, and multilabel classification support different types of image categorization requirements. Training data quality, validation, evaluation metrics, and representative images are important for building reliable classification models. For AI 900, remember that image classification identifies what an image represents, while object detection identifies objects and their locations. Thanks for watching this AI 900 learning video. For more learning content, tutorials, and real-time projects, stay connected with Zoom Data. Visit our website, subscribe to our YouTube channel, and follow us on Instagram. See you in the next video.